Hi, this is Julie Harland, and I'm your Math Gal. Please visit my website at yourmathgal.com, where you could search for any of my videos organized by topic. This is part 2 of absolute value inequalities, and we solved the following two inequalities on this video. In our first video on absolute value inequalities, we ended with this. How would we solve an inequality of this form? Absolute value of some stuff is less than k, all right, k is some positive number. To get rid of that absolute value and solve, we would take the stuff, whatever it is, and out of the absolute value sign, and we'd say negative k is less than stuff is less than k. Now, if it was less than or equal, then everything would just be less than or equal, etc. So how would we do a problem like this? What if I had absolute value of 2x minus 1 is less than 9 using this idea? Well, what it says is I've got some stuff in here, right? It's of this form, except just as less than, and it's a positive number. So to solve this, we have to take what's inside the absolute value here, okay, the 2x minus 1, right? And basically it gets squished between negative 9 and 9. If you remember, it has to do with distance. What it's saying is the distance from 2x minus 1 to 0, I could either go 9 spaces to the right or 9 spaces to the left of 0. And that's where we get this in between negative 9 and 9. And now we can solve this inequality. All right, so let's keep going. We're going to add 1 to both sides. I'm sorry, to all three parts. It's not quite like an equation because there's just not two sides. All right, so we have negative 9 plus 1 is negative 8. And now minus 1 plus 1 is just going to give us a 2x in the middle. And 9 plus 1 is 10. And lastly, we'll just divide everything by 2. Now, since we're dividing by a positive number, we don't switch the inequality sign. It stays just like it is. So we've got that x is between negative 4 and 5. All right, so what would this be in interval notation? The answer is between negative 4 and 5. So there is our answer in interval notation. And it's not an ordered pair, it's an interval. Remember, that means this is what the graph of the solution looks like. So let's say this is 0. How about I go by 2's? 2, 4, 6. Let's say this is 2, 4, negative 6. So what I'm saying is my solution is in between, not touching, negative 4 and all the way up to 5. So any number in this range, right, is going to make this inequality true. So it's a good idea to check, like one of those numbers at least. So what's an easy number to check? It goes through 0, so I'm going to see if 0 works. So let's go ahead and check just to make sure 0 works. So here's the original, remember? I'm going to do a little check right here. 2x minus 1 is less than 9. How about if I check x equals 0 to see if that makes the inequality true? So I put in 0 for x, right? And I want to know if that's going to be true. So can we do that? Inside the absolute value, I have 2 times 0, which is 0, minus 1. So inside the absolute value, 0 minus 1 is absolute value of negative 1. And is the absolute value of negative 1 less than 9? Well, what's the absolute value of negative 1? It's 1. So we know at least one of the numbers I have it going through works. To see if the endpoints are right, what you could do is plug in negative 4 and this should end up being equal actually, and you could plug in 5 and they should end up being equal. All right, so there's the solution in graphical form. Here's the solution in interval notation. So remember, the key is to have something in this form. Absolute value of some stuff is less than or equal to a positive number. Then we write negative of that positive number. So if k was 5, we would write negative 5. In this case, k was 9, so we wrote negative 9, right? The stuff, what am I talking about? That's the stuff inside the absolute value sign. So in this case, it was 2x minus 1. Right, so let's try another example. All right, we're going to solve this absolute value inequality. So this time we have the absolute value of 5 minus x is less than or equal to 2. So what I have inside the absolute value is 5 minus x. So whatever this simplifies to, when I take the absolute value, it's got to be a number less than 2. So whatever's in the absolute value, which happens to be 5 minus x, ends up being between negative 2 and 2. So what this is saying is it could equal negative 2, it could equal 2, or it could equal anything in between. So let's solve this inequality. So we're trying to isolate x in the middle here. So how about we subtract 5 from both sides to begin? All right, so I have a negative 2 and a negative 5. That's negative 7. Right, I have 5 minus 5, that's 0. And don't forget to bring down the minus sign in front of this x. It's not just x, it's a minus sign in front of the x, which I'm going to write as negative 1x. That's one of the most common mistakes, is to just bring down the x. And on the right, 2 minus 5, that's really just 2 plus negative 5, which is negative 3. All right, now what do? I haven't solved for x yet. I've got negative x. Negative 1x. So I'm going to divide everything by negative 1, okay? But remember, if you divide by a negative number, it switches all these inequality signs to the other direction. So what do I have, really? This means negative 7 divided by negative 1. Well, you're doing a negative divided by a negative, so it's positive. 7 divided by 1 is just the number 7. We have this greater than or equal. The negative ones both cancel out here, so I just have x. I've isolated the x, which is the goal in solving, right? And what do I have? Negative 3 divided by negative 1. Again, negative divided by negative is positive, and 3 divided by 1 is 3. So this is what I get. So how could we read this? 7 is greater than or equal to x, which is greater than or equal to 3. Okay? Well, that's the same thing as saying, let's say you're reading from right to left, that 3 is less than or equal to x, which is less than or equal to 7. So I can write it like that. A lot of people prefer to write it so it's less than. That way, always the smaller number will be on the left and the bigger number will be on the right. That's usually easier to read it that way. So what's the solution? How do I write that in interval notation? It's between 3 and 7, and I use the brackets because it could actually equal 3 and it could actually equal 7. It could equal 3, x could equal 3, x could equal 7, and any number in between. So if I look at a number line here, let's say that's 8 and here's 4, for instance, then this is how I would graph it using the interval notation graphing. Now there's only one way to really check any of these absolute value problems. There's always 3 things you would have to check. You have to check the endpoints, which are 3 and 7, and where the number in between. Since there's a solution, you're going to pick a number in between 3 and 7 and see if it works. If all 3 of those works, then we're sure that this is correct. So let's go ahead and just do all 3 of them here for our check this time. So the original problem, remember, is absolute value of 5 minus x is less than or equal to 2. And first let's check the left endpoint, x equals 3. So we're going to plug in 3 for x. So I have 5 minus, plugging in my 3 for x, less than or equal to 2. And we're trying to find out if this is really going to be true. 5 minus 3 is 2. Right? Absolute value of 2 is 2. And so we want to know if this is true. Well, remember, what does this mean? When I write 2 is less than or equal to 2, that's a shortcut of way of saying 2 is either less than 2 or 2 is equal to 2. As long as one of these is true, and that's certainly true, then yes, I've got a correct solution. All right, let's check a number between 3 and 7, since that should also be a solution. Any of these numbers will do. You could put the video on pause and try that on your own. You could try any number you want. You could try 3.5, 4, 5, 6, whatever you want. So let's see. I think I will check 4. So I'm going to plug in 4 for x and do the same thing I did up here. That's the absolute value of 1, which simplifies to just 1. And again, that's a true statement, because what does this mean when I say 1 is less than or equal to 2? It means either 1 is less than 2 or 1 equals 2. Which one, or as long as one of those statements is true, we're good. All right, so yes. So that means yes, 4 is a solution. So far, yes, that was a solution. Yes, that was a solution. There's only one more you have to try, and what will that be? X equals 7. So now we would plug in 7 for x. Okay. So we'd have the absolute value of negative 2 is less than or equal to 2. And what's the absolute value of negative 2? It's 2. And what does that mean? Either 2 is less than 2 or 2 is equal to 2. And are one of those two things correct? Yep. This is. So yes, that is the only way to truly check that your solution is completely correct. So down here we have our solution, right? There's the graphical solution and the solution written in interval notation. All right, go on to the next video. We just keep stepping it up, get a little bit more difficult problems as we go on. So there's a few more that we're going to work on with less than or equal, and then we'll move on to what happens when it's greater than or equal, and we also do a few tricky problems of both types. Please visit my website at yourmathgal.com, where you can view all of my videos, which are organized by topic.